Hi guys, welcome back to another Science Sunday. Hope you have had a wonderful start to your new year, new 2022. We're back with another episode of Science Sunday, things that you can do at home with your friends and family, maybe at school for like an investigation, but just in general, like learning about cool stuff in the world around us related to science and STEM. So today's activity, this week's activity, is making a self-crushing can. And so this is kind of like our goal, our end result. And you know, some people might play this off as like a magic trick, but deep down there's some great science behind it. So let's jump right in. So whenever we're doing investigations, as fun as they are, deep down we're really learning skills, right? So it's like our secret. So skills that we're going to practice today, including asking questions, developing, we're going to make our own model, which is always fun, and carrying out an investigation to kind of see what happens, right? Once you know the basic demonstration, then you can kind of go off in your own investigation with the questions that you have. And we're going to hopefully be constructing an explanation once you have a little bit better understanding of what's going on with the science. So along with that, no matter what science we're talking about, whether it's like a life science or physical science like physics and chemistry, there are these big cross-cutting concepts that span across all of our different science areas. So the ones we're going to focus on today are cause and effect, right? That happens a lot in the world around us. Something causes something else to happen. Energy and matter, which we know is all around us. And stability, which means like things just maintaining the way they are, not changing. And then the opposite of that is obviously things changing. So we're going to look a little bit related to that today. So first we're going to start off with a video clip of a tanker car, just to kind of set this up for you a little bit before it plays. And we're going to just observe what happens first and then talk about like what are the conditions that led to what we're going to see. Okay, so we're going to cue the video here. So this is a tanker car pulled by, you know, however many train engines, and this one implodes, right, or collapses on itself. Nothing was pulling on it or pushing on it. It appears to just by itself spontaneously implode to the inside and kind of crumple. So that's like pretty interesting. Definitely not something I've ever seen in real life, or that you would expect to happen. Tanker cars are built to be super strong. They carry, you know, liquids and things long distances. They're meant to last a long time. So that's crazy that this could possibly happen. So, you know, kind of what I'm wondering is how did the railroad tanker that's built to be very strong, very tough, collapse on itself, seemingly spontaneously? And this was actually something that was investigated by the Mythbusters, if you have ever seen their TV show. In their very last season of their show, they investigated this. They called it Tanker Crush. They were able to successfully kind of replicate that same effect. It's kind of based on like a legend, like all of their things are kind of myths. But they had a few caveats, right? Conditions had to be like just so. They're not just going to spontaneously implode like that. Obviously, that would not be a good thing for a railroad industry. And so what they found is, for the most part, is really not going to happen spontaneously like that. But if you're interested, it was in season 9, episode 3, if you want to watch an entire episode about this. So we're going to make our own model. I don't happen to have a railroad tanker car handy, but I do know that I have pretty good access to soda cans, right? So the shape is a little bit similar. It's made of metal. So this is going to be the basis of our model. So we're not going to be able to replicate it exactly, but we're going to make a model to investigate what happened. So for our model, we do need an empty soda can. You need a little bit of water, about 2 or 3 tablespoons. And then we need a bowl of really cold water, preferably like put a bunch of ice cubes in it. And then some tongs or some heat-proof gloves are going to be really important. If you're doing this at home, you do want to have some adult help you with the part that's involving the heat and whatnot to make sure it's super safe. But I'll show you the demonstration in a second and you can kind of see, but definitely get parental involvement on this one. And we are going to be using the stove as our heat source. So these are the materials that we need. Next, I'm going to show you the experiment that I set up at home with my two kids, Drew and Connor, and they are going to give you their observations and reactions to our demonstration. So we are setting up a model of, we're going to pretend this is like our tanker car, okay? So like trains, they pull those tanker cars and they have liquid inside. And we want to see what happens when we take the can, which right now has hot water. It's been boiling for a few minutes, and that water is turning from a liquid, right? When we see water as a liquid, right? And then it can change state. It can change to a solid, like these ice cubes, and it can change to water vapor. And then which is a gas, and we can't see that with our eyes, right? But we know that's what happens with water. So the water that's in this cup has been boiling, so we know some water vapor is inside the can. And what that's done is it's pushed out the air, right? The regular air that was in the can because it was empty. So we're gonna see what happens when we take it from super hot, right? And all that water vapor that's been building up and moving around really fast, like when you have a lot of sugar and you're moving around really fast. That's what those water vapor have done.
To like freezing
to the
cold.
Super cold, right? Because then those water vapor molecules start slowing down, right? Because they're like, oh no, it's cold. All right, so let's see if we can get this on our first try, right? All right, so you guys are telling what you see, what you want to know, what your reaction is, okay? All right, here we go. 1, 2, 3.
What the? That's supposed to break?
It didn't break.
I mean crumble. Why did it
crumble? Yeah, so we call that imploding. It basically, the sides crumpled in, right? I didn't do that even though I was holding the tongs. It crumpled itself from the inside when I put it in that cold water, right?
That was weird.
And look, all sides, it's almost like a square, right? The way that it crumpled, it has like these 4 little corners. Crumpled all by itself when we did that.
Is there still stuff inside?
Nope, there's a little bit of water. Yeah, all right, so that is our self-imploding or self-crumpling can.
Where did you put the soda so I can drink it?
It's all gone.
No!
All right, so next up, we're gonna find out why this happened. What's the science between our self-crumpling? Some people might call this magic, but we know there's science behind that, right?
Science.
So next up, we're gonna find out the science behind our crumpling can. All right, so now that you've seen the demonstration in action, you may be like ready to go in the kitchen and do it yourself, and that is great. But we also want to make sure we understand a little bit about what's going on, right? So when you're telling somebody about this and showing them your demonstration, you want to be able to explain to them why, right? So what's going on? So all in the air around us, right? This is like one atmosphere of pressure, right? If you push on your skin, that feeling you feel on your skin is pressure from your finger onto, your hand or whatever you're pushing on. The atmosphere, the air in around us also pushes on us, but just not to where we feel it like all the time, right? It's just a little bit of pressure. So there is air inside of our empty soda can, and there's air outside of the soda can, right? Unless you're doing this underwater. So before we do anything, right, there's no heat, there's just a can with a little tiny bit of water, a lot of air. So when we go to heat up the can, right, on our stove, we're heating up that little bit of water inside. And if you've ever made pasta and noodles or, seen somebody cook on the stove, you know that at some point when there is a pot of water or liquid on the stove, after a while it starts producing bubbles, right? We call that boiling. And that happens at a very particular temperature. When the water reaches that temperature, it boils, right? You've probably seen that from experience. So when that water boils, what's actually happening is an invisible process, invisible to our eyes, where the liquid, right, water is turning into water vapor. And this is happening in the world all around us, not only when you have something boiling on the stove, but this is a very accelerated way to evaporate water when you heat it up. So out in the atmosphere, that water vapor eventually goes into clouds, and we have had some, wet experiences in the last few weeks with our weather, where that water is now coming back down as rain, right? It kind of turns back into a liquid and is falling down as rain. A similar process is kind of happening inside this can. So we're heating it up. The water vapor is now kind of floating up, right? If that's a term you can visualize, it's kind of going upwards. And because this is open, what it's doing is it's actually displacing, or it's replacing that regular air that was inside our can to start. Because water vapor is very excited, right? It moves very quickly. It's bouncing all around the inside of the can. It's not stuck in one spot like the ice cube, right? Those molecules are not really bouncing around hardly anywhere. And they're not moving as fast as like liquid molecules are moving. Okay, so these are bouncing all around. And so what that's doing is it's actually like punching out the regular air that was inside the can. So now our can, after it's been boiling for a while, is full of a little bit of liquid still. It hasn't all evaporated, and a bunch of water vapor. So when I seal it, which is what they do to that tanker car when they're trying to replicate that experiment, when I seal it, and in my version, I flipped it over onto the ice water, and that didn't allow any air to get in, right? It was just in contact with water. So whether you seal it like with a cap or you flip it over onto that ice water, now there's no air coming in and there's no water vapor able to get out, and it's cooling down rapidly when I placed it into my ice water. So when those water vapor molecules are now cooling, right, they were super hot, super excited, moving around. Now they're cooling down, they start slowing down, and they're just like kind of bouncing around. So when they slow down, the pressure inside of our can goes down, right? So if you think back to our analogy with our skin, like pushing on it, now the pressure inside the can is a lot less, right? So it's like a lighter tap, a lighter pressure on your skin. But there's still pressure all around the can on the outside from the atmosphere, right? So what happens is the atmospheric pressure outside the can is now stronger than the pressure inside the can, and that pressure outside basically pushes more forcefully onto the can than it can push back. And so you get that effect where the can is now kind of crumpling in on itself. Going the wrong way here. All right, so here we go. So then we get that crunch, right? And there was kind of a little bit of a sound if you listen in the demonstration when this happens, right? So the atmosphere is pushing more on the outside of the can, causes the can to, seemingly just condense on itself and crumple, okay? So that's kind of the science behind this, it's obviously fun to also show somebody, but you want to be able to explain it, right, and understand really what's going on. So something really, we want to bring it back to that tanker. Like I said, in the Mythbusters episode, they did say that this does not happen like on a regular basis. So the idea is if you fill it up with steam or something like that and then seal it, like that's the myth, that it could just implode like that. So if you are able to replicate it, and if you watch the episode Mythbusters, they are able to replicate it eventually. Kind of what's going on? How do we take our demonstration with the can and relate it back to what happened with the tanker? It's very similar, just on a much bigger scale. So when the tank is full of liquid of some sort, or air even, there's pressure that's equal on the outside and on the inside, right? So it just stays how it is. However, if you're able to fill up the inside of the tanker with water vapor, okay, and then you seal it completely and close off any air being able to get in, technically you could replicate that experiment on the tanker as well. very similar to what we saw with the can. It'll crumple in on itself like we saw in the video. So very similar concept, just on a much bigger and stronger scale than our soda can. So something you could do to further investigate this, if you kind of try it and have a little success and a little bit of fun and want to take it one step further, you could change the temperature that you're placing the can in after. So mine was like a lot of ice cubes and water. It was very cold. So you could actually take a thermometer and measure the water temperature, and then have maybe 2 or 3 different water temperatures that you do this experiment with to see if it takes longer or shorter for that soda can to crumple, and then communicate your results, obviously, with someone interested in finding out what you discovered. So anyway, we hope this was a fun way to start off your new year with some science and discovery. And we're definitely interested to see if you can, if you want to share this with Elena, and what was your success and what did you pass on, that would be wonderful. But see if you can show and explain to someone, if you do this experiment, how your soda can seemingly crumpled in on itself, right? You can pass it off as magic, but you can also pass it off as a bunch of wonderfully explained science knowledge that you have about pressure and water vapor. Hope you have a great week, and we'll see you next time.